America is the most prominent melting pot in the entire world, and while diversity is quite possibly the most unique aspect of our country, it can often lead to language barriers in the workplace. Hi, my name is Haley Deng.
I'm Blake.
My name is Bernice.
My name is Kevin.
Hi, my name is Albert.
We wanted to overcome this language barrier while encouraging the continued integration of multiple cultures into the workplace, so we developed Scribe.
After talking with our SME, a woman with a hearing impairment disability, we learned that even though she used hearing aids and could read lips, it was especially difficult for her to understand others when they spoke with heavy foreign accents.
Therefore, to aid those with hearing disabilities better understand and communicate with their colleagues who may speak accented English, our team decided to create a software that enables speech-to-text translation for those who speak both accented and unaccented English. However, as there are a wide variety of accents that can be encountered in the workplace, we decided to focus on one of the most widespread of those accents, the South Asian accent.
At first, we wanted to use a program that would analyze the muscle movements in the mouths of individuals. However, the main issue with this proposal was privacy. We realized that it would be quite difficult to have to ask for permission to film in order to use our application. This would not only disrupt the workplace, but it would also draw more attention to the user's disability. We decided instead to focus on an AI that analyzes audio rather than video.
We initially looked into IBM's base AI model available for customization. However, due to some API authentication errors, we decided to move on. Next, we looked at the pre-trained ASR models available online, also known as automated speech recognition, but the prediction accuracy available was rather low and also required a lot of data to import into the app itself. Finally, it was decided that we could use the Google Cloud API service, and not only does this offer support for a variety of different accents, but it also runs completely on the cloud service, meaning that it is free of any sort of download. Next up, when it comes to language or accent identification, instead of creating our own binary classification model from scratch, we decided on a different idea: confidence levels. Confidence levels are much more efficient than these binary classification models because instead of having a separate program just to identify which accent is being spoken, these confidence levels output the highest likelihood that a certain accent is being used. So what makes us unique? Well, after researching our proposed experiment, we realized early on that there were no similar applications that worked well on the market. There are many that take speech and turn it into text, but these models often don't account for accented speech. The few applications that do look for different accents and give back virtually unusable transcriptions. Alright, and now I'll be going over a brief demonstration of our program. So, start recording, stop recording, pretty self-explanatory. Now, once you stop recording, that will actually be sent back to this program over here, which is our backend application, as a audio wave file. The other input is the accent variable, which is determined by the confidence levels located down here. Now, this all sounds a bit confusing, but once we run the program, we'll see what happens. For the purposes of this experiment, I'll be playing two accents, an English and an Indian one, from my computer.
Please call Stella. Ask her to bring these things with her.
The burning fire had been extinguished.
Now let's run the program and see what happens. As you can see here, the English audio file yields a very high confidence rate for the English model, and the Indian model has an exceptionally high confidence rate but much lower than the English one. The Indian accent audio file has a high confidence rate for the Indian accent model and a subpar confidence rate for the English accent model. That shows that we know which programs to run. For now, the application can only run locally. However, in future versions of this app, we hope to extend this to a web server such as Firebase or Google Cloud Storage. This will allow it to run properly on any sort of mobile application. Furthermore, the current state of the speech-to-text model causes the user to have to look at their phone constantly during the translation, and this can sometimes be misinterpreted as disinterest, as our SME has commented on before. Therefore, for future updates of the application, we could be adding options to translate accented speech to a standard output speech rather than a text format.